So, good afternoon, everybody. My name is Marcin Przepiorowski, and I will be talking about efficient test data management. So, two things about me. I'm working with Oracle since 2000, but I'm also working with other non-Oracle platforms. Basically, my main role was a DBA. For last 3 years, I'm working outside of being the production DBA. I'm also co-developer of Orasearch, the free AWR Ash repository. I used to be a blogger. I still try to blog, but I don't have enough time. Oracle Ace and a member of Oaktable. So that presentation is actually focused on the databases and the application environment, but I will not talk about technical stuff. Will be rather the vision and how to deal with the data, other than showing you the basic solution and step-by-step technical stuff. So agenda. Some real-life examples at the beginning, why we should think about test data management, why we should actually run the tests. What is the test data management in my opinion, how I define a good process. Then I will be talking about the virtualization as a solution for our test data management. And at the end, a couple of words about the security of our test data. Okay, so first of all, the test data are not like a whiskey or wine or any good spirit. Basically, they doesn't increase the value if they are old. So if you have 21 years old whiskey, it's probably better than 1 year old. If you have 21 years old test data, doesn't sound good for me. Why I'm saying about that? So I was involved in the migration project, and that project kicks off on the development environment which has been created 2 years before the project even kicks off. So if we are 2017 now, so think if you're starting your working on developing something on the data which has been taken from the production in 2015, so 2 years back. And the guys was working with that, and when we start asking questions, are you sure you are covering all use cases from the production because you have very old data? They said, yes, we have a list of all change requests from production. We apply all those changes to our code. Well, when we did the performance test like half a year before the real go live, and we take the data from the production, we run the code they spent around a year working on, they migrate like 70% of data only. That 70% which they had in the environment they got. The rest was unworking data, the new data. Basically, they missed two important changes which have happened to the production database. So basically, if you're starting working on something, do not assume that your data you have are production-like until they has been taken from the production quite recently. Second example, development project which was working for 18 months. It was actually migration from Forms to Oracle ADF, and the guys was working basically on creating new screens, adding new functionality, but they never think about testing the solution. So they have some test data generated by themselves. It was basically less than 1% of the production size, and it was quite typical solution. So we have a database, we have the application server and the browser. So it was working like a magic, but if you have 100 rows in the table, everything is working as a magic. So what happened then was this. Suddenly, when we migrate some production data into the development environment, the guys forgot to include some where clauses in the SQL. ADF was so nice that is actually hide that because application server was actually filtering data. So what happened when you add more data? All the data has been taken from the database to application server, And as we all know, server has been designed to filtering and joining data, and that actually blow up application servers and also database, because what happens if people don't get the response very quickly on the browser? They click refresh again or click search again. There was another thread, another session reading all those data from database to application servers to filter and return one row. They never think about that before. And so basically, when we found that issue, it was too close to go live to fix that, and they have to postpone go live again. So that means that if you don't think about your test data, if you don't have your proper test data to work with, you should never expect the good results. So there were two pessimistic examples. I want to share one quite optimistic one. So I was lucky to work with the pure DevOps environments, and with the developers working with DBA and OS teams to keep the production going. They have very good reason for that. The reason was the very close feedback loop from the development to production. The feedback loop looks like that. Your database is down. Sorry, Mr. Developer, wake up at the 3 a.m. and fix that. So the reason that were they able to fix everything was they have very good tools which allows them to create dev environment and refresh data using the web page. They have to go log in there, click refresh, and they can actually run the regression test. So with all those tools in place, those guys were able to deploy 2 or maybe 3 times per day fixes to the production side. But the tools they actually build the tools themselves with help of the DBAs and OS teams. Those tools help them to maintain this and keep this annoying stuff on the very little rate. You never create a code which doesn't have any bugs, but if you are able to test your code using the proper scale and test it based on the production data, it actually help you with in that case, with your good sleep. So as we know, the test data management is crucial during the test life cycles. There was a survey done, and around 80% of our organization is complaining that they will never get the test data on time, or refreshing data from the production is taking too long, and they have no idea how long it takes. Sometimes is because the process is manual, sometimes is because the process is so complicated that they don't have the data on time. Fortunately, 80% is a quite huge number, so I hope it will go down when people start thinking about test data and how we can manage data in a slightly different way. So how we can prepare the test data? There are, let's say, 3 main approaches we can think about. So we can do the clone, so we can clone the data from the production, and I personally believe that's the best approach. You can generate synthetic data. That's a good approach when you're developing the new application. I don't see a lot of reason why you want to generate the synthetic data if you have your production already in place. Or maybe you add a new feature, you want to do some scaling and do some performance tests. That's okay. And you can do the subsetting of the production because you don't have enough space to create your full clones. So basically, all those methods has pros and cons. So those are the one which is coming across everything. So preparing test data is time consuming, is resource consuming, and required skills. Yes, that's what it is. So we have to have someone who will be working on that. We have some resources, human and also physical resources like servers, and we have someone who know what to do. So if we take the step back, we can summarize all those issues, pros and cons, into 2 generic areas. The one is the manual work. So basically, if you have to manually do the stuff. It will take a time. That's the assembly line of the cars, and that was already improvement, because before the assembly line, each car has been built separately. When Mr. Ford introduced assembly lines, they speed up, but still there was a lot of people which has to do small tasks to make sure it's the car is at the end of the day, the car is assembling full and can be sold. So that's the one thing. The other thing, manual work and the processes, which is complicated process to refresh a database. So basically, why we complicating with processes? Maybe you outsource everything internally, externally. Maybe you have ITIL version 3 and you have created ticket for everything. And then the second person is creating the other ticket to help with the first ticket. At the end of the day, you have 5 tickets to refresh your data, because you have DBA, OS team, change management team, whatever team, security team. So you have a lot of tickets, a lot of processes to go through. How to resolve the problem? What is the best solution for that? Well, this. Automation. We still have someone who is controlling those robots, but the assembly line can be much faster, and the people who are maintaining those robots can focus on something else. They don't need to lose the time of doing this same job again and again and again. So DBAs don't need to spend that whole day refreshing your database and running Erman duplicate. They can do something which is more productive than that. In terms of the processes, what is the best solution for resolving this ticket madness is the self-service. If you give the developer or tester ability to refresh database when they click something on the screen, on the web page, you are done. The self-service is what they need. Maybe you still have to raise the change request ticket or something like that to make sure that what you are refreshing, everybody agree to refresh. But then just click the button. It should be done automatically in the background. So these two things are actually redefining the database administration work. So a lot of people are talking about, is the DBA still dead or alive? There's a very good article by Tim Hall on his blog about database administration and how we should redefine the role of DBA. The DBA shouldn't spend the time doing the basic stuff. They should maybe use the cloud, use the tools to go further. If you are a DBA, if you think about the career of DBA, I really strongly recommend that to read. And actually it's connected to what I will be talking about in terms of automation. So automation as a process to manage your data. So if we move forward, let's see what is the good test data management process, what I define as a good test data management process. So it's a process which allows me to deliver right size of data on time and make sure that the data set is secure. It allows me to quickly isolate and deliver to developers the issues the other team is working on. So basically we can share the database between different users. And also it allows me to have some kind of version and code control. So we can have some kind of history. So let's move through all these steps in more details. So what is the right size of database? Well, if you ask me, the right size of your test database is exactly the production size. Because if you think about these slides, is taken from some of the IBM slides. You are subsetting data, so you have 2 terabytes in the prod, and 25 gigs in development. Well, 25 gigs database, I can cache. No, I can't cache on my Mac because it's only 60 gig. But if you have the laptop, you have 32 gigabytes of RAM. You can put the whole database on your laptop in the cache, and that'll be flying without any IOs. With SSD, it shouldn't be the problem, but again, the scale and CPU. If you were here on the previous presentation, Pete was talking about CPU issues and the scale as well. So the right size is a size which allows you to find the issues very quickly. So if you develop something on the big scale, you'll be never surprised that if you migrate the code to the production, you will see the code doesn't work on the production. So I put the yellow, not red, cross here because there are use cases when maybe you can run the subsets. Not always, but maybe. So it's not really the red cross, never do it, but do it wise. Think about those 2 points always when you're doing the subsettings. Also, for some reason, people are used to say that subsetting is much easier to do. Well, you can do the subsetting only if you exactly know what the application is doing. Because you can't randomly choose the rows you take from 100 different tables to make sure that you subset the data. So if you have a database without referential keys, it's not uncommon to have those databases. How you find the rows, you have to know the business logic. So you have to have someone who knows exactly the business logic and create the rules for you, what to export and how to export. So the whole subsetting process could be a nightmare. Also, for some reason, developers love to create the complex structures. Sometimes they only know why they create that. My favorite example is creating one table as a history for every other tables. So they create one table called history, and if you change the address, the object was set as an object type history, and it went into the history table. If you change the name, the object was say, okay, it is a name, it's go to the history table, and then try to archive that table. Yeah, it's possible, but the rules how to archive the historic tables are very complex. You can do subsettings only easy. Okay, you can easily do the subsetting only if the application is supporting archiving. Because basically what you can do, you can take the full copy of your production data and archive everything you don't need to in development. But there's very few applications I have seen in my life which properly supporting archiving, so you can actually delete the data clicking something inside the application. So talking about the right size, why the right size is the problem? So if you have the production database as a 1 terabyte, we have 4 terabytes in our non-production environment. We have QA, test, dev, and some database for DBAs to work on. So basically, 80% of our disk space is non-production. Some people can say, okay, we are losing money here, a lot of money. So, but if you take a look on that, most of those databases are identical because they are a copy of the production database. So the blocks which has been not changed in those databases are exactly same across the whole fleet of the databases. So then you can start thinking what people did for operation systems, for servers when they have a lot of separated boxes. They start virtualizing that. So they actually create the one physical box which is bigger and put the virtual machines. From a cost perspective, you can save the money. Why do not do the same with databases? Why do not share the blocks which are the same across the whole fleet? And that's actually the concept of virtualization of the databases. So you have your production database, it's still 1 terabyte. You have take your production database into the storage, which support virtualization. So, okay, you have to take 1 terabyte here. I do not recommend running virtualization of the production storage. There are solutions like that, but most of people like to keep the production and non-production system separate zones, separate data centers maybe. So you're just taking the copy of the production into some storage. Then you can creating all your databases again, but you share the blocks you can. So when you share the blocks, the size of those databases is the size of the changes you generated at. Of course, if you update every single row in your test and or dev environment, you will actually generate another terabytes. But who is doing that? Most of people don't. So all of those databases are read and write. So from your perspective, they are normal databases. It's like using the virtual machine. You don't feel you are using virtual machine until you run 5 virtual machines on your laptop. Then you feel that you're running virtual machines because you don't have enough CPU. But if you have enough resources, you can virtualize something. And from database perspective, the database is up and running, is a read and write, but it's just sharing what can be shared. So virtualization allows us to have the right size of the database across the whole fleet of the databases, across QA, test, dev, and so on. So we don't need to worry about the resources anymore. What about the second point? How to isolate and deliver test data. If we virtualize something, it's much easier to move data from one point to the other point. It's like with the virtual machines. If you have the virtual machine in one ESX box, you can very easily move this to other machine. So actually you are moving your server without physical work. It's just online from one server to another server. There is no physical recabling or anything like that. What if you can do the same with the databases? So think about the scenario. The QA team found the bug and they're calling the developer, and what will be the answer? The answer will be no, it's working fine in our environment or on my laptop or whatever. And the QA said no, it doesn't. We can see the bug here, we can reproduce that, but developers can't reproduce the bug because they don't know if QA team, maybe they hack the data, maybe they do something stupid with the data before, maybe they use some wrong version of application, they never roll back something. So what is a solution? The developer has to connect to QA system, add all this debugging stuff and find the problem. But that could be potentially the problem even if you have separate solutions, if the QA teams want to work and so on. If you virtualize the data, what you can do, you can move a data from the one virtual database to the other virtual database. So basically, what you can do, you can create a snapshot here of your QA environment, and you can give that snapshot to developer. So the QA team can work. The developers see the QA data exactly how it was when they raised the bug. Developer work has been put aside, so it's not damaged. Can you do that without virtualization? Of course you can. It's not a magic. You have to take a backup of this. Sorry, take a backup of this, backup of that, restore that backup here, and put that backup here. Okay, we have a solution. It just take a while to run the backup. With the virtualization, you can do it much faster because all the data are in the same storage. You have to just repoint the storage from one point to another point. Problem, they just have his own database again. That snapshot can be deleted, can be there, doesn't really matter. Okay, the next point about ideal test data management is about the versioning code and data. What you are using for the versioning of the code? Everybody knows everybody are using Git, SVN or whatever. And the problem is you can even use the code versioning inside database. There are tools that allows you to check out and check in PL/SQL code in Oracle. The problem is with the data. You can't easily check out the data from database and check it in again. But if you have a proper tools, you can think about this. What if you have your production and the new version of application? Then you have another test environment or maybe development environment to develop the version 2.0 of the application while you still have the environment to fix the current version of the database. So what if you can branch your database and have two branches and easily switch between two branches of data? This same how you're doing with the code. You are typing git checkout version 2.0 and you have the new branch. Then you come back to a master branch and you have your old code. If you're developing something, that probably happened to most of people. At least it happened to me a couple of times when I was creating some complex query, I forgot the where clause. And instead of deleting one row, I delete 20 rows or 100 rows, or maybe whole table, or maybe I even drop the whole table. And of course I commit afterwards. So here is a problem. How to resolve that? Well, in Oracle you can do flashback database, you can flashback table from the bin or do something like that. But it depends on the vendor of your database. If you virtualize your databases and put into the common storage, which is doing virtualization, then you can have this functionality for every single database you are running on. So source control, yes, that's something we are dealing with. We know why we have the source control. What if you have a source control for the databases? What if you have something which is looking like that? So we have our virtualization, we have our version 2.0, and now we got the production issue, and we need to take the copy of QA system or maybe production system and fix creating the hotfix. We don't want to lose our version 2.0 database, so we're doing the branch here. We have QA branch, we have version 2 branch. Then we decide, okay, we fix the problem. We can do the snapshot of this and say, okay, if something goes wrong, I can come back to the snapshot. I can come back with the history of the data together with the code. So I can create the point in time recovery. Then I come back to my work with the version 2.0. And when you have a aha moment and you create something really, really good inside the database, you want to make sure that you have the snapshot of that. You commit this to your Git and say, okay, that's feature version 3, it's working now with that snapshot of the database. Because if someone will change your data, maybe it doesn't work. Maybe you don't know what the schema was. Well, maybe you don't know what the configuration data was. So if you have the history of the work, it's very nice to have. So basically you can think about this like having the trees. So that's the very simple code tree. So we have the master, we have a branch, we have some features. You can think that you have the same with the data. You can have bookmarks like here. You can have 2 branches as well. That's something which not only, but you can get this with the virtualization much easier than normally when you have to run with the backups, restores, and keep that data set somewhere. Okay, how we can virtualize databases? What are the solutions for that? Basically, there are 3 main solutions. So it's storage-based solutions. So basically, you have to have a storage, like, I don't know, EMC, NetApp, or whatever. There's a lot of storage now. And most of those vendors are providing you the possibility to do the snapshots on your databases. So then, or you have to buy the software which is virtualizing using those snapshots. Most of those vendors are selling that, or you can do it yourself. I know the big bank which spent half a year developing that solution, so they have solution based on the NetApp running for a long time, when they actually have the very nice portal when the developer can log in and said, okay, that's my development database, I want to refresh from that, click, done. It's take, I don't know, a couple of hours, maybe a couple of minutes. It was done behind the scene, nobody else has to work on that. DIY solution basically means that you have to have a team maintaining that, but you can do that. So the other solution is the file system based solutions. If you have the file system which is supporting snapshots, like ZFS, ACFS, and other file systems, again, you can buy the solution. You can buy the solution from Oracle, you can buy the solution from other vendors and do it, or you can build it yourself. Again, the same pros and cons. You have something created by your team or the other team they have to maintain, or just paying someone. The last solution, there are appliances on the market like Delphix, you can buy it, and we are doing virtualization. So you don't need to think about how to support that. You can just buy it and use and focus on what you need to do. Okay, so that was the virtualization part and automation part. What we What is missing is the second part, the processes. So as you remember, we got a very chaotic diagram of the tickets you have to raise to refresh your database. And we said the solution is to use a self-service. So that's one of the potential solution. You have your time flow snapshots, you have your snapshot, you just selecting your snapshot, click create database, and the database is created. So it's easy. You have to just have the solution, but at the end of the day, you don't think how much work is required from DBA. You don't need to think about this. It's actually done automatically. That was for Oracle. We have the same solution for Sybase. SQL Server. So basically, you have the time flow. You are selecting the snapshot, clicking. There is a refresh button at the here. You click refresh. You got your fresh copy of database. If you think this is too complicated, you can have the view like that. So it looks like the branch of your data sets. You can branch the data sets and just have stop, start, reset, refresh, restore, branch, and bookmark. So you have this, and with the self-service, you don't need to think what I have to do to refresh my data sets, how I have to, which ticket I have escalate to make it done. So the first step to have this is to have virtualization in place or full end-to-end automation. Virtualization make it much easier, but you can do everything I show you using Airman. Duplicate. You can do that. It just takes a long time to duplicate the database. But if you have the portal or some application workflow behind, which can give you the solution like this, then you are logged into a portal, you are selecting the snapshot you want to have, you are selecting the target database, and you got it. That's what we're looking for, because that means that you can focus on something you are paid for the productive work of development, not waiting for DBAs to provide you the fresh data sets. So the last topic I would like to talk about is the security of your databases. So basically, security is important, isn't it? Especially for the production database. You have to go through all these security requirements. And if you take a look at some statistics, I'm not sure it's the whole year or only half a year, but 2016 we got like 845 different security issues across different categories, and 30 million of personal data has been exposed to internet. But if you think about the production databases, that's your production. You have one copy of the production. Cool, but then you have X copies of your production data in non-production environments, and basically it's even more important to protect this because more people has access to that, especially developers, testers, everybody who are working on the application. So what the solutions are? Okay, for the production we have to encrypt the data. So if someone will take our backup of our production database, they don't have access to it. If we encrypt the data files, even using the technique we'll show you tomorrow about the hacking session, you can actually read the data set if they are encrypted. Of course, if you have the encryption key, then you can try to decrypt that, but it's actually adding more complexity. What about non-production data? How we should deal with non-production data? We have to give the data to developers and testers to make sure that they can actually do the job. It's very difficult to work on the data if you can't see the data, and you have to run the test case, and you can see the number one did that something. It's difficult. But if you mask your data so nobody can identify the personal data or financial data anymore, that's something you should deal with. You can start thinking, do we really need to mask data? Do we really have data we have to care about? Well, yes. especially this one, GDPR and General Data Protection Regulation, which kicks off this year, is it's very strong in the European Union. So basically, you are not allowed to have any personal data from the production system in test or dev. So you have to mask everything. There are other PCI, PII, other data masking from EU. So there is a lot of legal requirements that you actually have to protect your data. You have to mask your data. So yeah, 80% of, I already said that 80% of data is in non-production system, and you have to mask this. So what are the masking requirements in the eyes of the security officer? Well, that's simple enough. We have to be it has to be easy to audit, that the masking actually finishes without the problems, and that there is no exposure there. Nobody should be able to reverse the masking process, so developer should not be able to actually find the unmasked data. And it should be simple, automated, and repeatable. So every time we are running our refresh process, we should get our data masked. That's easy enough, isn't it? What about DBA and developers? I should put the developer picture here as well. So basically, if you're masking your data, it's very, very, very important to make sure that your masked data after masking process looks in same way for database optimizer. So think about this. If you are masking date of birth, you can. What is the easiest way to do so? Just update table set date of birth 1st January 1975. Done. Well, okay, you mask the data, nobody can see the actual data, even the optimizer. So when you run the query on your test environment, the optimizer sees, oh, there is one unique value. So there is no way to use index, full scan. If you actually run this query on the prod, there's probably more than one unique value from the day of birth. So you can have a different plan. And the same happen for, I don't know, any, selling, addresses, everything you're masking. You have to make sure the statistics before and after masking looks the same. So there is in same amount of unique value, there is the same amount of rows, and so on. If you have the correlation between data, you have to keep that correlation as well, especially if you have the extended statistics. So if you are masking addresses, if you mask addresses and said, okay, everyone in Poland are living in Warsaw, and the Warsaw is on one county in Poland, that is probably wrong. If you're doing in US that everybody from San Francisco are in the state of New York, that's probably wrong as well, because there is no such correlation in the real database. So you have to keep in mind how you're masking data to make sure that the rules are using for masking are clever enough to cover this and keep your cost optimizer with equally statistically good data. And of course, the last one, keep in mind referential integrity. After masking, your application is supposed to work. So if you are masking the primary keys, that's probably a bad idea. Until your primary key is some insurance number or private number, you have to actually mask. But then you have to update all the referential keys as well. So when we join those two things together, when we join the virtualization and the masking together, then we can think about the solution which allows us to have very good test data management. And when we have our mask data, so if we clone our mask data and virtualize our mask data, we can very easily provide enough copies of dev, test, QA environment using virtualization. And having this process allows us to have our test or development environment be really agile, really deliver on time. So if we start with our database in the production, the first step will be to mask and virtualize databases. So when we virtualize database, then we are creating the copies. So we have development, we have test, some other acceptance, whatever databases. So then when we have this, what is the end of this cycle? We have to deploy the changes to the production. And when we have this, basically we have to start from the scratch. So we have to refresh, mask, and go this around. So basically, if you automate the full process of this, if you automate the full cycle, then what you can do is actually provide, if you have to deploy your code 4 times per day, you can do that, because you can actually very easily refresh your data, run Jenkins job, which do your integration tests, and make it done. So if you think about, let's say, continuous integrations, if you have the Jenkins job which is compiling your code daily, if you have a database connected to that, you can have your database refreshed daily with the production data. So your new release of your code, your nightly builds, are tested against the latest production database. And you can automate that, and you can have very good quality of your code, because everything is running 24/7 testing. That there is no regression test, there is no regression application, there is no regression bugs. So this is what I would like you to take as an output from that session, that there are tools on the market which allows you to integrate your databases into the automation work you are dealing with during your development, that you can very easily refresh your production, refresh your QA and development database using the production data sets. The main goal is to automate everything. In my opinion, the best automation is to use virtualization. Then you have to think about security and mask the data. And at the end of the day, you got the good agile test data management process. So I'm almost end of my time, and I was the last one between beer and the party upstairs. So thank you very much for your time. I was asked to say that you should put the feedback form in the applications if you can. And if you have any question, I'm happy to answer the questions. If not, I will be upstairs around if you want to talk. Thank you very much.